This is Chapter 5, Lesson 3, Properties of Operations. So, a blank, a property is a statement that is true for any number. Okay? So, you may wonder if any of the properties apply to subtraction or division. If you can find a blank, you can find a counter example an example that shows that a conjecture is false, the property does not apply. Okay? So let's look at some examples. So it says, name the property shown by the statement 2 times the quantity 5 times n equals 2 times 5 times n. So the order of the numbers and variable did not change, but their grouping did. So this is the associative property of multiplication because I'm multiplying the numbers, okay? And associative, nothing moves, all right? So the next thing says, state whether the following conjecture is true or false. If false, provide a counterexample. Division of whole numbers is commutative, okay? So I can write 2 division expressions using the commutative property. 15 divided by 3, and I want to know if that equals 3 divided by 15. Well, 15 divided by 3 is 5. 3 divided by 15 is 1/5. So the conjecture is false. We found a counterexample. So that is 15 divided by 3 does not equal 3 divided by 15. So division is not commutative. Okay. My third example says Alana wants to buy a sweater that costs $38, sunglasses that cost $14, a pair of jeans that cost $22, and a t-shirt that costs $16. Use mental math to find the total cost before tax. Okay. So, I can write an expression for the total cost. You can rearrange the numbers using the properties of math. Look for sums that are multiples of 10. Okay. So 38 plus 14 plus 22 plus 16. I know 8 and 2 would give me 10, so I'm going to group them together. And 4 and 6 would give me 10, so I'm going to group them together. 38 plus 22 is 60. 14 plus 16 gives me 30. So 60 plus 30 is 90. So the total cost of the items is $90. Okay. There are a couple of try-it problems that are right next to this, but I want to talk about the pink foldable first. Okay, so the pink foldable actually has examples of the different properties. So I have commutative, associative, additive identity, multiplicative property of 0, and the distributive property. So the first one, commutative, okay, so it gives an example of what commutative is for addition and multiplication. Associative, remember I just changed the grouping signs. So commutative, I can change the order. Associative, I just changed the signs. Additive identity is when I add by 0, I get the same number. Multiplicative identity, I multiply by 1. Multiplicative property of 0, I multiply by 0 and everything equals 0. And then the distributive property for addition and subtraction. Okay, so all those examples, they should all be things that you're familiar with and have already learned, but here's just a review real fast, okay? All right, so now go ahead, try out the try-it problems, and when you're done, we will go over the answers together. All right, the first try-it problem says, name the property shown by the statement. Okay, so it says 42 plus x plus y equals 42 plus y plus x. So I didn't change any grouping signs, but I did change the order that these are in. So this is additive because I'm adding. So this is the commutative property. of addition, okay? You want to make sure you include commutative and addition in this because that actually does tell you exactly what property you're using, okay? So the second one I have is state whether the following conjecture is true or false. If false, provide a counterexample. So it says the difference of two different whole numbers is always less than both of the two numbers. Okay, so I'm going to pick two numbers. I'm going to say 8 and 2. Okay, so those are the two numbers I picked. So it says the difference of two different whole numbers. They're two different whole numbers. So difference I subtract. So 8 minus 2 gives me 6. Is always less than both of the two numbers. Okay, well 6 is less than 8, but it's not less than 2. So this has to be a false statement. Okay? Since 6 is not less than 2. All right, my third example says Lance made 4 phone calls from his cell phone today. The calls lasted 4.7, 9.4, 2.3, and 10.6 minutes. Use mental math to find the total amount of time he spent on the phone. Okay, so total amount, I'm going to add these together. 4.7, 9.4, 2.3, 10.6. Okay, it says use mental math, so I'm going to look and see if I can find anything that gives me close to 10. 4 and 6 would give me 10, and 3 and 7 would give me 10. So I'm going to rearrange these. 4.7 plus 2.3 plus 9.4 plus 10.6. Okay? 4.7 plus 2.3 gives me 7. 9.4 plus 10.6 gives me 20. 7 plus 20 gives me 27. So 27 minutes was how long Lance was on the phone for. Okay. And that is the end of lesson 3.